This is the weekly Fairground Jam where we go through different features of our testnet called Fairground. And we recently started doing more incentives. So last week already, we had quite not 2 incentives in a row in regards to rewards and staking. And thanks to you guys, we found a lot of bugs and things that we have fixed now. So with the last incentive, you guys managed to help us to address the auto top-up, the top-up functionality, where on the UI it wasn't possible to top up the full amount of newly associated tokens. So you went through the process, you associate the tokens, you stake them, you got rewards, you cashed them out, and then you started by associating the rewards again, and then you couldn't delegate the entire amount of tokens, and this is now fixed. This was the user interface bug, luckily not anything related to the core. And there was another user interface bug that the information display on the top right sometimes showed that the wallet is outdated, even it was the newest version of the wallet. And we also managed to replicate this, and it's also fixed by now. So yeah, this about this. Let me quickly introduce Klaus, who is with me here today, and I will ask him, like last time, a lot of questions, how the blockchain world works, how Vega works, and other things. And since in 2 minutes we have 7 o'clock, and then I will start first with the Raffle. I can already start explaining how it actually works. And there's actually also quite some questions for Klaus from classical computer science. Klaus, what's the best way to create a random number?
A secure random number or a non-secure one?
Let's go for the most secure random number. I heard it's
in
7.
cryptography, actually the best is that's called a true random number generator, and that's something that's building on quantum effects, for example. So real physical effect that is inherently by physical laws random. Like if you have a quantum measurement, for example, spin, then this is actually real true randomness, and it doesn't get more random than that. If you don't have that, because those things can be a little bit pricey, I think what we did last time, we needed real randomness, is put a hairdryer on the microphone of the computer and then take the lowest bit of the microphone reading, in the hope that the physics of a hairdryer generates enough noise that the lowest bit of the measured volume would be as random as possible given the circumstances.
What's with mathematical created randomness? So digits of pi, or I don't know, there's multiple other...
That's then called pseudo-randomness. So because if you run the same formula again, you get exactly the same randomness, which sometimes is what you want. Like if you want to debug, you actually want to say, this is my seed, so that's a value this starts with. That would then be the, say, the starting number where in pi you start looking. And then you get the exact same random sequence. So pi is random, but of course, if I know you're using pi and I see one of your keys, then I can have a very good guess on what your other keys were, because I know the entire sequence you're using. And that is then for cryptography, for example, not enough.
But hopefully for this...
Sorry?
Hopefully for this Raffle, so now we have 7 o'clock. So I can show you what I'm doing, and I think this goes totally in the direction of pseudo-randomness, but it also has the advantage that it can be replicated, so people can later see that as long as they have the core utils, that we are not faking anything here. And I explain you how it works, the Raffle, and not only you, but also the viewers. So what happened is we had all these people here, 387, who completed the incentive tasks correctly. And we said if there's more than 300, we Raffle. 300 of them will get 10 Vega each. So now we have the problem that we have 387 and basically need to reduce this to 300. And the command that I'm running is like this. So I have the list of participants, which you can already found on fairground.wtf/rewards. There we listed them. I can also post just this text file, which you can exactly see here. Then it goes to sort minus random, which I think is in core utils, and it should be the same on Mac as on Linux, but I only got confirmation from other Mac users that it works the same way. And here we have exactly this. You can run it without the random source, and then it generates a different list every time. And I'm pretty sure it uses some sort of values, physical values from the computer. I think it looks in some temperatures.
Oh, yeah, the standard is to then use some physical attributes of your computer. So if C has the same, so if you can generate a random seed that then uses, well, disk spinning doesn't really exist anymore. So in this, I'm a little bit old-fashioned.
And it can also, for example, use running processes and create a SHA on it and use this as random source on it. So, but I want that, yeah, people don't think, or that I use my own version of sort, which, yeah, that you guys can replicate it, and that we are not trying to do anything here. So I use the participants file as input, and then I'm posting it. Then I cut the first 300 lines, head minus n 300 takes the first 300 lines of this, and then it writes it to a file called winners. And if I do this now, I have the winners file, and I will publish it on both on Discord, so you guys can both see it. And yeah, maybe while I scroll through, some of you guys can already see if you're part of the lucky guys. And yeah, otherwise, this will also be tomorrow updated on the homepage. So at the moment, the rewards homepage shows the participant, and tomorrow this will be the winners. And if anyone wants to recreate this and make sure everything is fine, then you can go back. And we will do it every time we do Raffle, we do it exactly the same way. We get the query output, which shows everyone who participated and finished the incentive task based on our query that we run on the data nodes. And then we use this input file as source of randomness, and then cut it for 300 people or whatever the number is of people that are rewarded with tokens. So yeah, I hope this makes sense and is random enough for this live raffle. And congratulations to everyone who made it and got 10 Vega tokens. They will be on rewards.fairground.wtf next Friday. It takes a while to get the claim codes and everything, but you should also be able already to find the claim codes from the last incentive. And yeah, next Friday we have then the new one. So any questions about this, you can let me know on Telegram, and otherwise, yeah, I hope you guys, some of you are within the lucky winners. And now I use the time to finally ask Klaus all the questions that I ever wanted to ask, but had no one who has answers to it. So randomness we already discussed. So you said quantum effects are good. Actually, I remember that my computer science teacher in 7th grade told me the background noise of the universe is also excellent.
Probably, but I'm not sure what kind of equipment you need to measure that one.
The television, no? We called it ant football.
Is that background noise of the universe, or is this just other radio noise?
I haven't checked that one.
I think the background noise of the universe is pretty weak, so you may.
But it can't be so bad, because I remember that people actually discovered it through an accident. Some people were building some sort of radio, and then they were wondering what this noise is. And then
there was a 3 meter or 4 meter big antenna. And so it was not what I could build at home. but maybe it works. Maybe there's some how-to somewhere on the internet how to measure cosmic background noise yourself, which would be pretty cool.
Yeah, this we need when
I think most of the things, the commercial things usually go small and then go more into quantum effects. And I think for most people, the fan on the microphone method is good enough for randomness.
Okay, so now let's go to all the big questions I have prepared for you. Let me go through my list. Okay, the first thing that I have, you scared me and I haven't slept a single night since our last Fairground Jam, because you explained that in a BFT, proof of stake blockchain, 2/3 of the validators with the delegated tokens can basically steal all assets, right? This is correct?
Well, slightly different. So we have the communication with the Ethereum contract, and 2/3 of the validator, which is in this sense actually a parameter we can choose, can communicate with the Ethereum contract and then authorize transactions on there. And that's a parameter we could actually increase this. The problem is the higher you have it, the lower the number of people that could just go home and then you can't contact anything anymore. So if you would say it needs all validators to do this, then if one validator just disappears in a hole in the earth, then we are stalled. For the consensus protocol, essentially 2/3 of the people can run their own consensus protocol. And then of course they could also run two, and then they could create forks easily, which would be very visible as soon as two people with a fork meet, because it's signed by them. So you could immediately prove something went wrong. But essentially they can ignore the other third and just drive on the blockchain by themselves. But the worrying part is a communication with the Ethereum contract, and that's something where we're also working on to make that more secure and build in some roadblocks that asset theft is even for 2/3 not possible.
Oh, that would be cool. Then my question makes no sense anymore, but I still ask it. How are rewards connected to the asset value? So basically, yeah, like, am I always incentivized, or like, let's say that the price of like a Vega token and anyhow should game theoretically related to the trade volume and to the assets at stake? Or could you end up in a situation where basically there's 100,000 to secure the network and 100 million in assets?
I think it goes the other way around. So from a protocol point of view, because we don't slash, so you could say, but that's not what we are doing, that all delegators are liable for their validators. And then if the validators steal money, we take their Vega tokens and distribute them to the people that had the damage. Which in this case, I don't think would work, because if all our validators turn out evil, then that probably would affect the price of the Vega token as well. So you have some feedback there. I think the real feedback is more Vega is generating a certain amount of interest. So if we have more trading volume on Vega, then more reward money is generated. And I can't see that you have a token that then generates 300% interest and the token price would just go up to, I have no idea what the fair interest rates are these days, but then the token rate would just go up. So the interest rate is what people expect a crypto asset to have. So in this, there is a relation. The more assets we have, the more trading we can expect to have, and more trading generates more revenue. And that should, I mean, again, no price speculation here, then also influence the Vega token price. But we don't use the Vega token as a collateral for security for the validators. What we can do is the more revenue we generate, the more generous we can be in paying more validators. So then we can also scale up to more validators, and then the chance that 2/3 of them go bad is lower. So if we have more money to pay out there, then more professional people will be validators or will want to be validators. And that's again then an indirect security effect.
Okay, yeah, this Makes sense. Okay, so you said let me understand one thing. So what happens now? Let's say I'm a bad validator, and I find the other 2/3 who also are bad validators with me. And yeah, the delegated tokens that I'm using are obviously not mine. They belong to someone else. So these I cannot.
So sorry, say again.
So let's say I'm a bad validator, and I'm conspiring with others because I feel like there's some asset that I want to steal. So what exactly is now my punishment? Let's say like I'm completely anonymous, like a DAO that has like a very good reputation or whatever, and no one knows really who and what where's running it and what people are involved or whatever. So what would be now my punishment for trying this?
Well, at the moment, but also at the moment, there are not a lot of assets to steal. The punishment is essentially reputation. And right now, we don't have totally anonymous validators. So right now, there's validators that validate on other chains too. So if they would start stealing something in the next 3 months, they would actually lose off bigly by reputation. Eventually, well, that would mean that 2/3 of the delegators delegated to completely anonymous validators, which is already, I would hope there's some sort of community effort to know their validators, and that I can't come with, hi, I'm someone, please delegate all your tokens to me. So that's, I mean, the whole idea is a validator that wants to get more voting power needs to build trust with the token holders. And you don't build trust if you're a completely anonymous entity that just popped up yesterday. So in this, there is some protection in there. In the end, if 2/3 wanted to steal an asset, we could add another slashing. So it is something where we now want to observe how the relationship with community and validators work, and also what community expected, and also what validators expect. So we could ask the validators to pay a deposit. So once Vega generates nice revenue, it's probably easy to say you need to put X ETH deposit in to be a validator, and if you misbehave, that's gone. But I would expect that nobody would go there to steal then $100. So if somebody manages to round up 2/3 of validators, then there would be a very, very long and very, very big con.
I love what you said first, that when validators validate on different chains, basically their image and reputation like affects more and more revenue streams of them. So like their reputation has like instantly measurable monetary value, and then this is, I think, very, very powerful tool.
And we are also working on additional roadblocks that an asset theft is just not possible. That, for example, if they want to go above a certain level of transaction, that there's a bigger forum that needs to acknowledge that may even involve the token holders. But that's all work in progress. So right now I sleep pretty well, because theft would just not be worth the damage. And then the goal is to scale up in the number of validators to make the 2/3 collusion. And it's not only 2/3 collusion, right? You need to have 2/3 collusion without anybody noticing you're doing this. And if you ever try to organize a surprise birthday party, that's hard. And by the time we have enough money that somebody would say, screw my reputation, and afterwards I go to the Bahamas, then we should have additional security measures in there. There's a couple of exciting things out there, but they're non-trivial to get to work. So
cool. Okay, now I finally can sleep well again. Okay, I think we have talked so much about rewards and staking already, like last time. And since you're here, I want to ask like a more general question, which I hear a lot, and I don't know what is the best answer to it or exactly. So what is the biggest advantage, or what things we can do with Vega, because we are layer 1 blockchain compared to like a layer 2? And basically this includes also like what are the limitations of current layer 2s on different other blockchains. But yeah, what is like the main amazing thing about being an L1?
I think the first thing that comes to mind is speed. So if we would run on Ethereum, for example, Ethereum has a 10-minute block time. We are aiming for a second or two. And if we want to convince traders to leave Wall Street and go to DeFi, we need to offer them a speed that's at least not obnoxiously slower than what they're used to now. So a second or two they can live with, maybe 3, but they can't wait for 3 minutes until the trade, for 10 minutes until the trade is evaluated. The other thing, and that's specifically currently an Ethereum problem, is of course cost. So on Vega, you can submit a transaction for free, and the validators are then paid by trading fees on completed trades. And we couldn't do this if we would run on another blockchain, where we then have a cost structure. And seeing the Ethereum gas price, you submit a trade, the trade fails for some reason, and you just wasted $100 if you do it at the wrong time.
But with layer 2, at least, it should get that you can bundle and bunch like a lot of stuff. So it should be on layer 2 at least significantly cheaper than doing it as just like a bunch of smart contracts running directly on Ethereum. But if you think of Lightning Network or something, how is it there with like costs and processing speed?
That should work better, yeah. And I mean, in a way, I'm not sure if we are that different from a Lightning Network, because we run our own chain that then sorts things. That just has a lot of security properties already. And in the end, we do coordinate assets with other chains. So at some point, the distinction there gets a little bit blurry between what is actually what layer. So in some sense, you could actually interpret us as also we are a Lightning Network that does trades and then reports at some point when somebody withdraws the results back to Ethereum, although we don't use it to secure the chain yet. So I think the difference there is getting a little bit blurry, but right now we only have costs if you actually withdraw from the Vega system, or if you put money into the Vega system, and everything else is just our own validators. So we can control the cost structures. We can do things like anti-front running, which again is very difficult to implement if you depend on somebody else's blockchain. But yeah, as I said, it's a bit blurry where actually layer 1.5 is and layer 1, and I never really liked the whole layer structure anyhow. And there could even be an idea that for additional security, we just make a checkpoint on Ethereum, which was actually very close to a Lightning Network, right? And that would be a doable thing.
While you mentioned checkpoint, just like a question, I think Vega has checkpoints, how the network can be restored. But this is one of the things that I never really understood about Bitcoin. What is the practical value in always keeping the entire chain and not like at one point creating some sort of checkpoint or like just state where you like record all the funds in different wallets, and if it's like deep enough, like 1 year old or 2 years old, I think the reorg security or whatever has absolutely no value. So what is the value for Bitcoin to always keep the entire ledger?
Actually, I think Bitcoin has a checkpoint functionality that was used, but the last checkpoint is more than 5 years old now. So I think it's actually still in, with more the added security thing that if somebody comes now with a quantum computer that can hash very fast and would start to uproll the entire Bitcoin chain, then at least you can say something is secured. I think most clients actually do start at, we believe this is a state from whatever to 18, and we believe everything before without checking, because otherwise my clients would get too big. For the general chain, that's in a bit of a trust thing. So in Bitcoin, you have no idea who your validators are. So signing off a checkpoint is hard. And then they just keep the entire, because it's a very, very trustless and very paranoid scene in that sense. So they don't want to trust anyone. And if you keep the entire chain, then you can say, well, the worst thing that can happen is a fork, but nobody can lie about anybody's anybody's status. But it does have some functionality. I also think it has some functionality where it says everything older than that. I don't run scripts anymore because that's too expensive. I just believe that has been checked enough. And you could have, and as I think they did have a checkpoint where you say everything that's more than 1 year old is okay. But for some reason, that's not used anymore. And they rather store the whole chain than putting trust in there. And I think in Bitcoin, it's also more doable. So in Vega, again, we are aiming for 1, 2, 3 second block time. So the point where the Vega size will overtake the size of Bitcoin will come pretty fast. And we have a lot of computation because we are running complex market protocols there. So a rerun of the Vega chain versus rerun of Bitcoin without the scripts will take much, much longer. So we need some form of, if a new validator comes in, that they don't need to do 3 years of computation before they caught up with the others. And since we know who our validators are at any point, it's also easier to certify the checkpoints.
Yeah, I mean, it's basically the same security. If like validators would like agree on a checkpoint, then and they sign it, it has like the same security as the chain itself, no?
Maybe a little bit less, but roughly the same, yeah. But one other thing that's an advantage of Vega is because we're not running a currency, we're running a market. So at some point also the market data is totally irrelevant. So the most amount of the data we have in the chain at some point doesn't play any role anymore, because that's a market that may not even exist, and checkpoints can then just dramatically shorten the amount of data you have to store.
Yeah, and I mean, historians or people that are interested or one can anyways query a data node at any point and store it at one point, but it doesn't need to be available on the network for forever, right?
I don't know if you don't want a historical chain somewhere that has a whole history, but that would also hope that storage stays cheap. And
you see, I got a lot of questions here. The questions I should ask you is next. Can I become a validator on the mainnet? What can I do to become a validator? I think this is a community-driven process, right?
So we have a concept of progressive decentralization. So the validators that are there now were voted in by the community, and it's a fixed set for now. So right now you would have to convince the community and the other validators. There is a desire to have more. Eventually, there will be a function that you can be pretty automatically a validator once you represent a certain amount of tokens. So the idea then would be you essentially announce, I want to be a validator, then people can start delegating to you, or you bring enough own tokens with you. And once you go over a certain threshold, then you're automatically in being a validator. For now, it's community driven. So it's what people would call this proof of authority, but the authority is a community. So I'm not sure. Proof of community sounds wrong.
No, I think the community should. I don't know, like, but I like the idea personally that the community has like a say in this, because as you said, it's also about like the reputation about a validator, and like choosing validators is something where humans probably can be helpful, right?
In the end, it always does. That's what the whole delegated proof of stake is, that you need to get delegations. So in the beginning, you need to get votes, which is sort of indirect delegation. And at some point, it will just be automatically get to be known in the community. So if you want to be a validator now, if you didn't do it already, get active on the community channels. get known, show your skills, and then when you announce you want to be a validator and the network is open for more validators, then it should be hopefully easy to get the required delegation to start operating.
Okay, now comes the hardest questions, the last one. Can you give like a rundown about the different proof of stake algorithms that are out there? Like there's so many, EOS, Cardano, and it feels like you read the same concept with epochs and stuff over and over again. And why exactly do we choose Tendermint? Why we think
How much time do we have for that? Okay, so there's basically 3 approaches. One is the one that got inspired by Bitcoin, which is actually the youngest one. That's the longest chain-based protocol. And this is where people then more or less directly translated proof of work protocols into proof of stake. And there the idea is somebody is elected a leader, chooses a block, communicates the chosen block, next guy is leader. So in proof of work, you elected leader because you did the work, and proof of stake by some random function that takes your stake into account. And if you have a conflict that 2 people think they're leader, or a leader starts 2 chains, the longest chain you see wins. So that is the approach that Bitcoin does. That's the approach that Ethereum does, that Ethereum 2 will do. I think most Cardano definitely does this, but with a bit more scientific background. And the advantage there is that you can scale up to a pretty high number of validators. The disadvantage is you can have forks, so you usually don't have finality. And again, for us as a trading app, you need to know what the status of the order book is, so you can issue your state. You can't say, well, that may be the order book, but it may not be, because there can be a fork that I didn't see yet. So we can only operate once we have finality, and this is where, like if you do a Bitcoin transaction, you wait a couple of blocks until you really believe that Bitcoin transaction is through, and that can cost you whatever 10 seconds, which then goes into latency for us.
In Bitcoin, it costs you minutes.
Yeah, well, Bitcoin has a slower block time anyhow, but if you have a fast chain, then it still costs you a couple of blocks you need to wait, and even if they generate 2 blocks a second, then that still costs you a while until you have sort of some sense of finality. Then the next thing is the Byzantine fault-tolerant protocol that builds on work of Miguel and Castro and Liskov from '99. And that's a voting-based protocol where you again have a leader, but then the leader communicates with all other validators, and 2/3 of them need to vote on your block in a double voting scheme. And
what is a double voting scheme?
Well, you have a pre-vote and a main vote for protocol internal reasons. So if everybody just voted, that's what I saw, that's not enough to get agreement. So you have 2 rounds of voting, and then you can be sure 2/3 of the parties saw 2/3 of the other parties do something, and then you're sure this is actually the only outcome that we can have here, and everybody will come to that conclusion. That's what Tendermint does in a slight variation. Hot stuff, the thing that now Meta is building, works on a variation of this. So this is the most common voting based protocol. And then there's the other approach, which is not that used. It's the asynchronous protocol. That was actually what I used to work on. And that's now in Honey Badger, but not used in a lot of protocols in practice. That's essentially also a voting-based protocol, but it's leaderless, and it builds on randomization. You have a couple of people that all act if they were leaders, and then you run a protocol that chooses one of them after they proposed a block, and that's in the block you have. That has the advantage that it's a little bit more robust, but generally a little bit slower than the BFT-style protocols.
So the leader is needed for the reward logic as well, right?
Not necessarily. So in most longest chain protocols, the easiest way is that if you generate a block, you just say, and hereby I grant myself also a little reward. We could do this too, but we're not doing this. We are giving out a reward based on stake people have, and there is some performance measurement, but it's not only leader based. It will also be participation based. Did I participate in the rest of the protocol? Have I been fast or have I been sluggy, and so on. So most longest chain protocols, that's the easiest way you can implement it, especially if you're registrationless like Bitcoin, where nobody knows who the validators are. We know who our validators are, so we have an easier time just handing out a reward every day and not needing to have to tie this necessarily to being a leader. And then you have hybrid protocol, where it gets really funny. So what Ethereum is doing with Casper, that they have a longest chain protocol, but they tie it with a finality gadget, which is essentially a variation of the BFT protocol. So they're trying to mix best of both worlds to get both the scalability of a longest chain protocol and the finality of PBFT. And now you don't look very convinced anymore.
No. There we run again what you said initially, that you don't like the layer concept anymore, because then is it like layer 2, layer 1, or like what is it still one concept? Yeah,
it's very similar. Like in Ethereum, they really call the finality an extra gadget, while other protocols have it baked in. So it's really hard to now distinguish this. So I would like to have everything as modules, but then not talk about a layer concept, but of a modular design concept.
What is the trade-offs between you call it Honey Badger, the second one, and BFT? So you said like it's slower, the Honey Badger concept, but more robust, right?
So the BFT protocols have a timing assumption in there. So if I'm a leader and I don't do anything, then someone at some point needs to complain, this guy didn't do his job, let's skip this block. And if your timing assumption is right, then that speeds up things, speeds it all up. If your timing assumption is wrong, then either you killed a perfectly good leader because you were just optimistic about how fast the internet is today. So I didn't hear from you in 10 milliseconds, so you're a bad leader. If it's too long, then you can just sit there idling, waiting for the timeout and for a leader that has gone. So there's a lot of art in there in getting the timing assumptions wrong and handling bad leaders. The randomized approach needs a little bit more protocol rounds, but it's completely asynchronous, so there's no timing assumption, and it just runs as fast as the network allows. And that's actually why I liked it more. Everybody acts as a leader, and if I don't act as a leader, then I'm just not passing the next vote on who actually the leader was for that round. So it goes ahead more steadily, but it takes a little bit more time. That's the price. And as a lot of things, everything in this area is a bit of a trade-off. So that's the main trade-offs.
Yeah, like that's, I think, the basic thing that everyone learns soon when entering the chain, so the blockchain space. And people always say this is better than this. It's usually completely different trade-offs that different projects are doing. And this is also why I think it's so cool that you explained all the different proof of stake approaches. Because
maybe one more thing on Tendermint. So the other thing that is often ignored, if your protocol is 5 or 10% better, in the end doesn't matter. I mean, the genius of the guys behind Tendermint is they managed to build a community. And I can write a new consensus protocol in 2 weeks, and I'm not a very good programmer. I cannot write anything that comes close to the whole framework with all the error handling and lower level message passing protocols, getting the signatures right. This is where the real work is. So if somebody had chosen a randomized protocol and built an ecosystem like Tendermint, we would probably use this. And in the end, in practice, maybe see very similar results. But there is also a lot of work in building a good community that actually keeps the whole ecosystem alive. And if somebody now comes with a protocol that's 10% faster than Tendermint, but there's one guy called Bob who's the only person who maintains it, you wouldn't want to use that.
Yeah, that's huge. It's, I think, a concept that you have everywhere in computer science, why some programming languages and other frameworks, why they don't have adaptation, or for example, why Python was eating all the space in artificial intelligence and in data visualization and these kind of, because the community is just so strong. It doesn't mean that Python is so much better than like everything else, but once you have like the community and they build more, and then the ecosystem actually makes a difference. That's, I think, really good point about general technology adaptation, that like everyone tries to find the reason why something wins, like in the core fundamentals, and then he says, oh, this is 3% better than this, so this should actually win on the long run. But the community and adaptation and how many people like have built amazing stuff around it, that's actually the much bigger impact on everyone who wants to use it than the performance of the core mechanics.
Mm-hmm. And then
I think like this is
also like Python, that Tendermint gets more flexible. So if you need something slightly different, so this is something where all blockchains are currently still need work. That if you need something slightly tweaked, that you don't have one big monolithic software block and you have no idea what your tweak affects, but that you have one module that you exchange. It's also something I'm talking about since a couple of years now.
And last question. I think we already do like very long streams. I'll let you go, but now I just want to understand one last thing while you're here. It also, Tendermint is up and running and working, while I think for the longest chain proof of stake algorithms, is there any big project that already made it work? I mean, Ethereum, with their Ethereum 2.0, I mean, obviously they have the legacy cases and it's for sure like not easy for them. But also it seems like there are some theoretical issues that are not solved yet.
Well, that normally doesn't stop people from doing stuff anyhow. I think, for example, Cardano is already working. So it's the problem with Ethereum is it's much easier to start a new blockchain with nobody yet using it. And then what's the worst that can happen if you forgot about something, your blockchain that nobody ever heard about fails. Ethereum is so big that if they make one mistake, and even a small mistake that just allows for a little bit of fraud, doesn't need to be a total collapse, then the impact is huge. So all the chains we know have to tread much more careful if they go into this area, and they really need to look at all the theoretical problems and solve them first, because otherwise somebody will exploit that. Well, if you start something new that isn't that used yet, then you have a much easier time to get it run first and worry about the theory while you go. So I don't think that's a particular weakness of longest chain-based proof of stake, that is just turning a ship like Ethereum around is a massive undertaking. And I have for the people that are like really replacing the core of everything they're doing on the running system, while there's millions of dollars being moved every day.
Okay, yeah, no,
if you work for a big company, so we can afford to just make a software update and push it out. In Microsoft, I probably would need to ask 5 levels of quality control. My manager have other 9 people co-sign it. So yeah, now we need to ask quality control too, but we're still much more agile than Microsoft in this, because fewer people die if something goes wrong.
Okay, I have a Windows gaming computer, and it doesn't feel like when they do updates that so many people have actually checked it. But I no, of course, it was just a joke. No, I completely understand what you're saying, and yeah, I think there's some concepts that whoever like works with technology, the ecosystem is the role, but also like the bigger your use case is and more people uses, the slower you must be, because the more robust and stable must be the next update and upgrade. And therefore you have like way longer release cycles
And
for
they
example,
also have a lot of momentum in the business case for the validators, because all the mining rigs will be completely useless if they change to proof of stake. So how do you take your validators with you if you make it, or the miners with you if you make a change like this? And so they have really interesting challenges in there that as a newcomer you don't have.
That's true. I still hope they get it done, because this would be good for the gas price.
Oh yeah, absolutely.
So yeah, fingers crossed to the Ethereum crew.
Well, I also hope, just for the sake of burning energy. So it's a bit of a religious debate, but proof of work is using up a lot of energy. And I think people are trying to just move the miners somewhere where you have spare energy anyhow. But it definitely is a problem that you essentially burn stuff to validate chains and using other protocols. But that's very quickly going to a religious debate here. So
yeah, because like, yeah, as you said, like there's
multiple already
accounts.
stakes on the do people on the chat already start with religious debates?
No. So we get questions about when mainnet, obviously, which is around the corner. Yeah, so okay, let me quickly one more time, because this is the end of the stream, show everyone the outcome of the winners, and I will also post it in the Fairground channel, Fairground testnet, and then it will also be on the homepage tomorrow for everyone who was late. And you need to look very carefully and spot your name. And then, yeah, let me see. You guys can see my screen. Okay, so here, for everyone who missed it, these are, let me scroll to the top if this is actually true. Yeah, so yeah, this is the list of the winners, and if you see your name here, then you won. But the way we choose the winners is completely reproducible. So everyone that is in the list of participants, which were the 387 people, was used as random source for sort. So this means if you on a Mac, I hope on Linux they use the same util sort, and then it should be the same outcome, but on Mac, that's definitely reproducible. And then we just cut the first 300 lines after randomizing the list of participants. And then we wrote it in a file called winners. And yeah, one more time, slowly scroll through it. So if you see your name here, this means you will get a claim code for 10 Vega tokens on rewards.fairground.wtf. And all the instructions follow us on Discord to see it. Yeah, and again, thanks a lot for participating. It really helped a lot. We found 2 big things that we improved now. And yeah, the next incentive is also around the corner. So yeah, stay tuned for this. And thanks a lot, Klaus. I really cannot say thank you enough, because I really feel like, okay, there's a lot of questions that I have, and like talking to you and someone who knows so many things from so many angles, it's always super interesting talking to you. And yeah, now I think everyone who was watching the stream now understands proof of stake much better, checkpoints much better, and the importance of community and technology ecosystems. So yeah, like we had like a quite wide-ranged conversation, and I totally enjoyed it. So thanks a lot for taking the time. And now, like, yeah, have a great evening. Same for the community. And I will have one last check if there's any last question, but I don't see one. So thanks and have a good evening. Same to the community. And yeah, I hope I can go home without rain, because I don't have rain clothes. And good evening. Bye-bye.